Hello children, in today's class we will be discussing about the acceleration and retardation. Children, this is a third class on kinematics. In the previous two classes we covered in detail about distance, displacement, speed, velocity. Links are given in the description. Go through those videos so that you get a complete command on the concept. And each and every concept is related definitely. So today's concept, whatever we are going to learn about today's concept, 100% related to the previous class. I mean what? We should have some previous knowledge to have a better understanding about this today's class. Okay children, fine. Now as I told you that today we will be discussing about the acceleration. Rather let us say that yes, we are going to get the feel about the concept of acceleration and as well as retardation also. Children, so to understand about acceleration, first let us consider any vehicle or object which is in motion. Let us take one example so that it will become very easier to us understand the concept of acceleration. For suppose children, here let us say that at a time 0, let us say that the velocity of a vehicle is 0. Example only. Okay. So let us say after 1 second, its velocity might be like a 2 meter per second. Next, after 2 seconds, its velocity, let us consider like a 5 meter per second. After 3 seconds, it is like, it's a 6 meter per second. After 4 seconds, it might be like a 10 meter per second. 10 meter per second. Now, if you can see this example, children, that particular vehicle velocity, keeps on changing with the time. But we want to know at what rate it is changing. At what rate it is changing. So here, if you can see children, from here to here, okay, its velocity is increased by 1. Means from here to here, its velocity increased to 1 meter per second and 1 second. Here 2 to 5, which means what? Velocity is increased by 3 meter per second. From here to here, 5 to 6. 1 meter per second, and from here to here 4 meter per second. Means at what rate of velocity of an object is changing. So children, it is not always increasing only. Yes, we can take example where the velocity of an object keeps on decreasing also. Children, it is not a matter whether increasing or decreasing. First try to understand. So there is a change in velocity. At what rate the velocity is changing. So regarding this change in velocity only children, a special physical quantity gives information about this change in velocity. That special quantity only we can call it as a acceleration. So simply what children, acceleration is what here? The rate of change of velocity. Children, I repeat, very important. See, the definition seems to be very simple. Yes, you can learn like this. But understanding it will take little bit time. Okay, so let us spend time today, that took quality time, so that to have a feel of acceleration. Children, the rate of change of velocity is called acceleration. So if you can see here children, from here to here, so from here to here, so it is a 2 minus 0 per 1 second, right? So from here to here, it is 3 meter per second change per 1 second. From here to here 6 minus 5, it is 1 meter per second. And from here to here 4 meter per second. Okay, now. So this is meter per second. So this is going to be 2 meter per second square. This is 3 meter per second square. And here is 1 meter per second square. And here it is 4 meter per second square. Children, meter per second square means how we should understand. This is very important. So anything, if any acceleration value, how to understand that? Children, it is 4 meter per second square. So you have to look at like this, 4 meter per second it is. So you should understand that. Means in this between these two time intervals, in this time interval children, you should understand that the vehicle speed is increasing 4 meter per second means in each 1 second the velocity of an object keeps on increasing. 4 meter per second, 8 meter per second, 12 meter per second. In this time interval I am talking actually. Okay, so 4 meter, see 4 meter per second, anything children, anything it is. So x meter per second square means what you should understand like this, x meter per second means that particular vehicle's velocity is increasing x meter per second in each second. If it is like a minus y meter per second square children, yes, this you should see like this, minus y meter per second. So that particular vehicles or objects velocity decreasing by y meter per second. Is that clear? So this is how actually we have to visualize about the acceleration. So acceleration is a rate of change of velocity, means at what rate the velocity is changing, that information is given by a physical quantity called what children? Acceleration. So simply acceleration you should write like this, not just velocity by time change, it's wrong. So some students they write it's acceleration, what actually? So velocity by time, no, it's wrong, it is. So it is change in velocity children, change in velocity by time, change in velocity by time. Is it clear? Change in velocity by time. Simply, for example, initially body has velocity u and after time t its velocity is v. Let us see that. So v is the final velocity, u is the initial velocity. So in simple terms we can write acceleration is equal to v minus u by t. So t is actually t2 minus t1, but initially it's t is 0, then you can write a is equal to v minus u by t children. So children, as you know, velocity is a vector quantity and acceleration is a change in velocity, and obviously here acceleration also vector quantity only, it is also vector quantity only, and its SI units are children. So it's a meter per second. So it is going to be meter per second square, and the CGS units are centimeter per second square. So simply this is about the acceleration children. The rate of change of velocity is called acceleration. Okay, so acceleration is equal to change in velocity by time. So it is a vector quantity. SI units are meter per second square and CGS units are centimeter per second square. Clear? Fine children. So here you make it one note, sir, as it is a a vector quantity, then whatever its direction, children, this is very important. Very means very much important. So here the direction of acceleration. So the acceleration is parallel or anti-parallel, parallel or anti-parallel to the velocity, anti-parallel to the velocity, but always in the direction of force, net force children, very important, always in the direction of net force. So this is a very important point children. Acceleration is always in the direction of net force acting, and it is a parallel or anti-parallel to the what we can say change in velocity, to the change in velocity. It is not velocity change in velocity, that is delta v. It is delta v. So acceleration is always either it is a acceleration in general, it is a parallel or anti-parallel to the change in velocity, and it is always in the direction of net force applied. It is always in the direction of net force applied. Is it clear? Okay, fine. So to have a more feel about the acceleration, let us take one more example. Children, have you copied this? Okay, or else let me take here. For suppose children, here let us say here is one vehicle. Okay, so let us take it's a vehicle A, and let us take here is one more vehicle. What type of vehicle children? Might be car. Okay, you are getting, sir, it seems to be car only, but is it? Okay, let us consider like that. So it's a car children. So both are in motion. So this car A children, let us say that it is moving with a 100 meter per second. Sorry, 100. See, I am saying 100 meter per second, but writing 10 meter per second. Children, This kind of errors are called, gross errors. We'll be discussing the types of errors. Means something is there in your mind, but something you'll be writing on paper. Did you face any time like this? This kind of errors have you committed? Okay, so we think something. So we thought of writing something, but something is written on the paper or somewhere else. Okay, gross errors. Okay, so here it is 100 meter per second velocity. The acceleration is 1 meter per second square. Let us say the second vehicle is moving with the velocity of 1 meter per second and acceleration of 100 meter per second square. 100 meter per second square. Can I erase this, children? This part? Yes. So let us see the difference. So just the numbers are different and you may get wondered, sir, what makes a difference in that, sir, that much? Okay. So look at it, children. So first vehicle, its velocity is 100 meter per second and with moving with acceleration of 1 meter per second square. What does it mean, children? It means let us say that its velocity is initially 0. Okay, so it's given 100, sorry. So 100 meter per second. Okay, so it is 100 meter per second initially. Okay, after 1 second it is 101 meter per second. Okay, next second it is 102 meter per second. Next second it is 103 meter per second. So this is a situation, this is a motion about this car A. What about car B, children? Yes, initially let us say its velocity is 1 meter per second, but after second its velocity is 101 meter per second. Next second it is 201 meter per second. Next second it is 301 meter per second. Children, look at here. So in these two situations, which situation do you think it's more dangerous? Second one means its velocity suddenly changes. Children, imagine 1 meter per second to 100 meter per second. 101 meter per second. 101 meter per second to 201 meter per second. How rapidly the velocity changes. Okay, so acceleration is how much here? 100 meter per second square. Of course, you may get doubt. Sir, what if it is a minus 1 meter per second square? Yes, simple, children. 100 meter per second, next 99 meter per second, next 98 meter per second, next 97 meter per second, keeps on decreasing. Okay, so as you get an acceleration negative, which means what? Force acting in opposite to the direction of the motion. Don't worry about it. We'll discuss in detail about the retardation. Okay. So this is about the axle. Children, get the feel. This is very, very important. If someone says the acceleration is 100 meter per second square, with that we should understand how actually the velocity keeps on changing. Okay, children, you may get wondered, sir, can these kind of situations happen? It might happen. The reverse also you can situate. For example, a car is going very fast. Suddenly something is going like 100 meter per second, 100 kilometers per hour, let us say that. If something comes across, then the driver has to apply sudden brakes, right? Then he has to bring 100 kilometer per hour to 0 kilometer per hour. He has to bring actually. Then only everything goes fine. So there, sudden decrease in the velocity. Yes, it can happen. Okay, children. So this is about the acceleration. See, it's very important. Meter per second square. It's a plus means the velocity is what? The velocity is increased by that much amount for each and every second. So 100 meter per second square means how you should see 100 meter per second. So velocity keeps on increasing by 100 meter per second in each second. In each second, the velocity is increased by 100 meter per second. So 1 meter per second square means what, children? 1 meter per second by second. So in this case, the velocity of an object increases by 1 meter per second for every 1 second. So this is about the acceleration. This is about the acceleration basic concept. Okay, just copy this. Clear? Okay, fine. So now, children, we discuss. See, the acceleration is the rate of change of velocity. Children, the velocity, there might be a change in velocity in a uniform manner and even non-uniform manner also. So let us take a situation, children, here. Let us take one situation. So let us say that initially the velocity is 0 meter per second. Okay. Next, after second, let us say that it's a 2 meter per second. After one more second, it is 4 meter per second. Next, it is 6 meter per second. Next, it is 8 meter per second. So, it is like a for every 1 second, let us say that. For every 1 second. For every 1 second. Now, let us try to calculate here acceleration, children, here. So, acceleration is equal to final velocity minus initial velocity by time. So, 2 minus 0 by 1. 2 meter per second square. And here you can see here 4 minus 2 is 2. By 1 is 2 only. So, here also acceleration is 2 meter per second square. And if you can notice here 6 minus 4, it is 2. 2 meter per second meter per second square. And this is going to be also 2 meter per second square. So, if you can see here, children, yes, here acceleration is constant throughout the journey. Acceleration is a constant throughout the journey. Such a motion only we can call it as a uniform accelerated motion. So, what is uniform acceleration? What is when you can say that the body has a uniform acceleration? So, the changes in velocity, not velocity, a difference is there. Velocity remains constant, change in velocity remains constant. So, velocity remains constant means what? 0. Okay now. So, what we can say, velocity remains constant means like a 2 meter per second, 2 meter per second, 2 meter per second. So, here velocity remains constant. Here there is no change in velocity only. So, no acceleration at all. This is not at all accelerated motion. But here notice here, there is a change in velocity but in a uniform manner. Uniform manner. Such a acceleration only we can call it as a uniform acceleration. We can call it as a uniform acceleration. Uniform acceleration. So, when you can say that a body is in uniform accelerated motion, children, yes, if that changes in a velocity should be a constant. So, velocity should change in a constant manner. Then what is the best example for this? Yes, children, bodies which are moving, vertically under the action of gravity. So, for suppose, children, here an object is there. So, it is falling. So, initially its velocity is 0, let us say that, towards the ground, okay, and the velocity keeps on increasing. Children, change in velocity means what? It's not always increase only, it can be decrease also, okay na? So, here the velocity keeps on increasing, but at what rate? It increases such a way that the acceleration throughout the journey is constant actually. The change in the velocity. So, that's what we can take near the Earth's surface, we can take A is equal to G is equal to 9.8 meter per second square will take at every point 9.8, 9.8, 9.8, 9.8. So, the acceleration remains constant. Such a motion only uniform acceleration. Now, children, what is a non-uniform acceleration? Okay, is it clear? Can you erase this? Yes. Now, let us see one more example here. So, the speed is 0 meter per second only. Next, it is 2 meter per second. Next, it might be 7 meter per second. Next, it might be 1 meter per second. Next, it might be 5 meter per second. Means for each second only, the velocity keeps on changing like this. So, with this you can understand the particular vehicle is not going on a smooth road. It might be rough road, very rough road. It might be, during rainy season, you don't know how the road is, you may increase the speed, decrease the speed. Due to that, if it is, up and downs are there, it's so difficult, right? So, children, here if you can see acceleration, no? So, 2 minus 0, children, it is for every 1 second, for every 1 second. So, 2 minus 0 by 1, it is 2 meter per second square. And here it is 7 minus 2, 5 meter per second square. And here it is 1 minus 7, children. Oh my God. What is this? 7 meter per second. So, retardation, more brakes you are applied, I think so. So, it is a minus 6 meter per second square. And here it is. So, let us take some, okay, here let us have some, 5 meter per second. So, this can be minus 2. And here let us do 1. So, this will be 4 meter per second square. So, children, here 2 meter per second square, 5 meter per second square, minus 2, 4. There is no, uniformity, right? So, here the velocity, there is a change in velocity, but not in a uniform manner. Such a acceleration only we can call it as a non-uniform acceleration. We can call it as a non-uniform acceleration. Children, you should not see about the velocity. You have to see about the change in velocity. That is what actually acceleration is. If the change in velocity is uniform, then you can say the uniform acceleration. If the change in velocity is not a uniform, like this example, so it is called as a non-uniform acceleration. Clear? Is it clear? Just copy it. Okay, 3, 2, 1. Yes. Yes, so here, if an object or any vehicle is going with a non-uniform acceleration, let us say it's a non-uniform acceleration, then we can talk about the acceleration in a given time. Fine. So, the acceleration in time t, children, acceleration in a time t, or the acceleration at a time t, at a time, very, so this is what actually even we discussed for speed and velocities, right? So in a given time, means you can understand that yes, there is a what we can say change in time in a huge manner. So you have a limits, so from this time to this time, but whereas at a time means yes, that particular time. So I don't have much time, tell me the acceleration, at that moment only acceleration. But here, yes, I have some time, you tell me, you take, okay, 1 o'clock to 5 o'clock. So what is the change in velocity with respect to that time? Okay, fine, children. So here, if the acceleration you are calculating in a given time, for suppose children, at a time t1, okay, the velocity is, let us say, v1. After time t2, the velocity is v2. Means there is a change in velocity with respect to the time, children. So this change in velocity by time, this change in velocity, that is a delta v by delta t, we can call it as a average acceleration. We can call it as a average acceleration. Means you are talking about the change in velocity in some time interval. In a time interval you are talking about. Okay, so change in velocity by change in time will give you what, children, sir? Average acceleration. So it is in between. So if we are discussing about the change in velocity in a given time interval from t1 to t2, we have a time. So in that time duration, what is the change in velocity? That is given by actually average acceleration. Now come to the at a time t, at that time only, means what here? The time interval is almost 0, but not 0. So 1 second and 2 seconds. Between 1 second and 2 seconds, some time is there, right? Yes, I want acceleration in that at that time only. I want acceleration at 0.05 second. I want acceleration at 0.005 second. Means almost 0, but not 0, children. Okay, so the acceleration of any object at a given time, at a particular instant, is called instantaneous acceleration. So instantaneous acceleration. So how can you define this, children? Yes, limit delta t tends to 0, then delta v by delta t, this can be written as dv by dt. Children, here don't get confused. Delta v is change in velocity only, dv is change in velocity only. But what is the difference? dv means very small change in a small interval of time. Okay, na? So this only we can actually call it as a rate of change of velocity. Rate of change of velocity. Children, it is given by actually the slope of velocity time graph. The slope of velocity time graph gives rate of change of velocity. It is dv by dt. Nothing but what, children? Instantaneous acceleration. It's nothing but what actually? Instantaneous acceleration. Fine, children. And when you can use this formula, when the velocity is the function of time. Very important, children. So as you are using instantaneous acceleration, You can calculate by using this formula only when here velocity is the function of time. Velocity is a function of time, which means what? Velocity should change with respect to time. Then only you can use this formula. If not, look at here, children. So here acceleration. Okay, let us take. I am not going to write every time instantaneous. So acceleration is equal to dv by dt, right? Children, this you multiply with the ds. ds is the displacement, and divide with the same displacement, change in displacement only. Anyhow, when both will get cancelled, this value will be 1 only. Okay, can we write this like this? So ds by dt I will write, dv by ds we can write. So ds by dt into dv by ds. Children, same thing, ds gets cancelled. But children, ds by dt what? This is rate of change of displacement, is called velocity. So here acceleration is equal to, we got velocity into ds, sorry, it's a dv by ds. Children, this is also acceleration formula, this is also acceleration formula, this also we can use. But when you can use this formula, you know, when velocity is, look at here, so velocity is the function of displacement. Velocity is a function of displacement. Velocity is a function of displacement. Is that clear, ma? Velocity is the function of displacement. And children, this also, look at here, more what can we write here? Acceleration is equal to, it is d by dt of velocity, right? Yes. But velocity is what? ds by dt. Substitute here. So this can be d by dt of ds by dt. So this can be written as acceleration is equal to d square displacement by dt square. Very, very important. Very, very important. Means if a velocity is given, they will ask you to calculate the acceleration. Just differentiate once over. But if a displacement is given, they will ask you to calculate the acceleration, children. Yes. First you differentiate the given displacement, you get the velocity. Then one more time also you have to differentiate to get the acceleration. Okay na? Chalo, copy this. Can I this 3, 2, 1 is a negative. Children here. So since that time we have been studying that acceleration is a change in velocity. But change in velocity means how we should understand. Because velocity is a vector quantity, it has a magnitude and as well as direction. So children, change in velocity means can happen in 3 ways. So change in velocity, what we can say, the change might be in magnitude of velocity. So magnitude of velocity is equivalent to the speed. I mean what? Change in speed. Second one, magnitude is not changed but directionally change. Direction of what? Velocity is changed. Then also it is accelerated motion. Even both can change, magnitude and as well as the direction of the velocity. That also can be accelerated motion. Children, acceleration, body can get acceleration. So because due to 3 reasons. If the velocity magnitude is changing, acceleration will be there. If only direction is changing, direction of velocity is changing, acceleration will be there. Both magnitude and direction are changing, then also acceleration will be there. Now let us discuss in detail, children. So let us take example, okay now, where first one let us see the situation where only magnitude of the velocity is changing. Children, magnitude of velocity is nothing but what actually? Speed. Magnitude of velocity is nothing but what, children? It's a speed only, right? Okay, now fine. So what happens here? So only the magnitude of the velocity is changing, then also body has acceleration. Look at here, children. So let us consider the motion along a straight line path. So its velocity keeps on changing, means only magnitude is changing. Look at here, magnitude is changing, but direction is not changing. Direction is along the straight line path in the same direction, even it is not coming back also. It is going along the straight line path only, forward direction only. So there is no change in direction, only magnitude will be changed. Okay, fine, children. Now here also you have some acceleration, right? That acceleration only we can call it as a tangential acceleration. What is it called? It's a tangential acceleration. Very, 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 very important. Now, sir, tangential acceleration, tangential acceleration we can represent with the t. So tangential acceleration is produced only when there is a change in the magnitude of the velocity, but there is no change in the direction of the velocity of an object. So tangential acceleration comes into play. It will see, okay, is the magnitude of the velocity is changing or a direction. If the direction of the velocity is changing, no, it won't come. No, I don't want to come. If the magnitude of the velocity is changing, yes, it is my time to enter. So that is what actually tangential acceleration. Tangential acceleration is produced only when there is a change in the magnitude of the velocity. Okay, now. So magnitude of the velocity changes when either the acceleration is parallel to the velocity or anti-parallel to the velocity, which means what? Force should exert on the body in the direction of motion. Means what? Acceleration is in the direction of velocity or acceleration is parallel to the velocity. If a force acts on the body in opposite direction, which means what? Force is acting opposite to the direction of motion, means what? Acceleration is opposite to the velocity, which means what? Anti-parallel. So children, if any object here, so let us take one object here. Okay, so here velocity and acceleration. So both are in the same direction. Children, so when a body is going in a straight line motion, children, so there is no point in discussing about the direction. It is all about the magnitude. So magnitude of velocity is nothing but the speed only. So we have to talk about the change in speed. If the acceleration is in the direction of velocity, that is both are parallel to each other, then its speed increases. Then the dot product of AV is positive. You may get one doubt, sir. AV is equal to positive. How you will get? Okay. So A dot V, look at here. So A dot V, let us recall the dot product. This can be written as AV cos theta. When both are parallel, theta is equal to 0 degrees. So then it will be AV only. Simply it is the magnitude of A, magnitude of V. So it is positive only, right? Yes. If not, for example, velocity is like this and acceleration like this. So it's like a retarded force is acting on that. Then what happens, children? Here acceleration is anti-parallel to the velocity. Then the speed up, children, don't get confused. Sir, you are talking about the acceleration. Why? From where this speed came? Children, speed is nothing but what? Magnitude of the velocity. Here we are talking about the magnitude of the velocity. So in this case, speed decreases, then AV will be negative. The dot product of acceleration velocity is negative. How? Look at here. So A dot V can be written as AV cos theta. But here as it is anti-parallel, the angle is 180 degrees. So that is AV cos 180. Children, cos 180 is minus 1. So AV into minus 1 minus AV. Okay, children. So this is all about the tangential acceleration. Children, tangential acceleration is produced only when there is a change in the magnitude of the velocity, but there is no change in the direction of velocity. Okay, just make a note of it. Means in this case, acceleration might be parallel to the velocity or anti-parallel to the velocity. Okay, done? Can I erase? Yes. Now we take the case where acceleration is perpendicular to the direction of velocity. See, in a previous case, we have we had a situation where acceleration and velocity both are either parallel or anti-parallel. Now look at here. So here is, this is a direction of velocity. Okay, and this is how actually acceleration is acting. So means what here? The angle between A and V, angle between these two is theta is equal to 90 degrees. So if this is a situation, children, then what happens, there won't be change. Children. So tangential acceleration can be written like this. So dV, so it's the magnitude of the velocity, right? So change in the magnitude of the velocity by dt. Simply we'll be using dV by dt. So that is nothing but what, children? Okay, nothing but what actually? Tangential acceleration. So when there is a 90 degrees angle between acceleration and velocity, children, only direction changes, but there is no change in the magnitude. For suppose here a body is going like this with a 5 meter per second. If acceleration is acting perpendicularly, yes, it goes like this, but with the same 5 meter per second only. Okay, if acceleration is acting continuously, it may not go like this straight, it will go along a curved path. That is different. Okay, we'll come to that point also. So here children, very very important. So if there is only change in the direction of velocity, but there is no change in the magnitude of the velocity, as a result the acceleration so produced called what children? Centripetal acceleration. Very very important children. This again we will be studying in a circular motion. Very important. Centripetal acceleration. Centripetal acceleration. So centripetal acceleration is produced only when there is a change in the direction of velocity, but there is no change in the what we can say magnitude of the velocity. Okay, fine. So in this case children here, so A dot V, this can be written as AV cos theta, but theta is 90 degrees. So AV 0 and something, it will be 0. So here A dot V, the dot product of acceleration and velocity is how much? It is a 0. Clear? So here we discussed about the tangential acceleration and here centripetal acceleration. Okay children. So this is where only change in magnitude, this is where only change in direction. Children, when there is only change in the magnitude of the velocity, as a result the acceleration produced is called tangential acceleration. If there is only change in the direction but there is no change in the magnitude of the velocity, as a result the acceleration so produced is called what? Centripetal acceleration. So here we have tangential acceleration, centripetal acceleration. And you may get one doubt, sir, in a first case velocity and acceleration are both are like a parallel and anti-parallel, whereas in a second case it is 90 degrees. So other than this also can happen, right? Theta can be other than 0, 180, even 90 also. So in that situation, what happens? For suppose children here, the body is going like this one, velocity of the body is in this direction. So always you don't expect either the acceleration to be in the direction of parallel, anti-parallel, 90 degrees, right? So other than 0, 180, 90 also, it possible is there, okay, practically. For suppose here, acceleration is acting in this direction, hence force is acting. Children, whenever I am talking about the acceleration direction, the direction of acceleration is always in the direction of net force. So you should understand force acting in this direction. So such that it is a theta. Now what we should do? Yes, let us split acceleration. Let us resolve the acceleration into two rectangular components. So this is a horizontal component children. Yes, this we can write as a cos theta. This is a cos theta and this is going to be a sin theta. A sin. So the first one is actually it's a cos theta and second one is what children? So it is what actually horizontal component ax. This is ay. Okay, are you able to see my any lighting defect? Let me check. Yes children. So now if you can see children, a cos theta. So this is a horizontal component. This is what actually a sin theta. Children, see, means this component of acceleration will try to change the only magnitude because see parallel. But whereas this component is, it is a perpendicular component, right? Perpendicular component. This is parallel component. So the acceleration which is acting in the direction of velocity changes the magnitude of the velocity. Changes the magnitude of the velocity. So it is nothing but what children? Tangential acceleration. Tangential acceleration. Whereas the acceleration which is perpendicular to the direction of velocity, this what actually changes the what children? Only direction but not a magnitude. So this is a centripetal acceleration. Means both accelerations, tangential acceleration and centripetal acceleration acting, which means what here? If acceleration is other than 0, 189 degrees children, then what is happening here? Yes, there is a change in velocity and as well as there is a change in the magnitude. As a result what will happen? Yes, so body will go not like this. If it is going like this, it will go in a curved path. So this concept, we'll be discussing in a two-dimensional motion. Don't worry, in detail we'll discuss actually. So if acceleration and if the angle between acceleration and velocity is other than 0, 180 degrees children, so there is a change in the magnitude and as well as there is a change in the direction of velocity, which means what? Yes, so in this case tangential acceleration and centripetal acceleration are taking a part. Children, see, in the first case only tangential acceleration is coming to play. In the second case, only centripetal acceleration is coming to play. Whereas in third case, centripetal acceleration and as well as what we can say tangential acceleration also coming to play. Hope you got a feel. Yes. Now let us restrict our discussion to the one-dimensional motion. You may ask, why not for a 2D? Because we are discussing what in a kinematics, we are discussing about the bodies which are moving in a straight line path. Now let us see how it will be this centripetal acceleration, tangential acceleration. Point H. Children, let us consider, I am telling you. So now we are going to completely concentrate on one-dimensional motion. So let us take a situation where a body is initially going to 5 meters per second and acceleration of 1 meter per second square along a straight line path. So the direction is like this. Children, if you can see, so 1 meter per second square, let us say it's a minus 1 meter per second square, right? Why always place, you make it out. So okay, minus 1 meter per second square. So then here what happens? 4 meter per second, it is 3 meter per second, it is 2 meter per second, here 1 meter per second, and is 0. Still, can you see that because velocity is 0, acceleration is 0? No. Why? Because acceleration is not just velocity. Acceleration is change in velocity. And here what happens? Minus 1 meter per second, minus 2 meter per second. You make it out, sir. What does it mean? It means that, I think a retarding force is acting. The body velocity keeps on decreasing, but along the straight line path only. So there is no change in direction, right? Along the straight line path only. And here body stopped for a while. Then what happens, children? Actually, I have shown like this, but the body moves back. So motion will be like this. But along the straight line only, the only magnitude of the velocity changes in this case, but there is no change in the direction. So the direction is not changed. This is very, very important. So in a one-dimensional motion, children, the one-dimensional motion, so there is a change in the what we can say magnitude of the velocity, but there is no change in the direction of velocity. Which means what here children? So here let us recall once again. Tangential acceleration is what actually? This is the change in the magnitude of velocity. Simply it is speed, change in speed. Simply it is a change in speed. But whereas centripetal acceleration is due to the change in the direction of velocity. Children, is there any direction? Is there any change in the direction? No. Which means what? Centripetal acceleration won't come into the picture here in one dimensional. Very, very important. So the centripetal acceleration is 0. Children, very, 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 very important. In a one dimensional motion, only tangential acceleration will come into the picture. The centripetal acceleration is 0. That's what I said, children. In two-dimensional motion only, we will consider. I mean, it's not our wish to consider. Yes, that comes into the picture. Okay, so in a one-dimensional motion, children, body is going along a straight line path. In the one-dimensional motion, so only tangential acceleration comes into play. Which means what? There is a change in the magnitude of the velocity, so-called speed, change in the value, but there is no change in direction. That's what centripetal acceleration is 0. And moreover, children, here, what is this value? The dot product of tangential acceleration, centripetal acceleration is 0, right? Why? Because tangential acceleration is either parallel or anti-parallel. Like this it will be there. Either parallel or anti-parallel to the direction of motion. And the centripetal acceleration is perpendicular. So this will be how much? 90 degrees. So the angle between tangential acceleration and centripetal acceleration is always 90 degrees. So this we know that here, this can be written as AC cos theta. So as theta is 90 degrees, cos 90 is 0. So this will be 0. Clear? Fine, children. And one more thing here, just before we discuss like this, right? So this is a tangential acceleration and here is a centripetal acceleration. Then how can we calculate the resultant one? Yes, so this gives you the resultant acceleration. So here, as per the parallelogram of law of vector addition, children, yes, you can write here the magnitude of the acceleration can be written as here AC square plus AT square. You may get one doubt, sir, what about plus 2AC AT cos theta? Theta is 90 degrees. The third term is going to be 0. So this is how actually you can calculate. So when centripetal acceleration and tangential acceleration are in a picture, then how to calculate the resultant acceleration? Yes, by using this formula you can calculate. Is it clear, children? Just copy this. Fine. Now for example, children, if angle, see, we are talking about when the angle between acceleration and velocity is known. What if the acceleration, the angle between the acceleration and velocity is not known, but still we need to calculate? Okay, now first suppose look at here now. V dot A. This can be written as magnitudes. V, simply it's a magnitude only I am writing. A cos theta. But children, here A cos theta is what? Recall once again. It is nothing but what actually? Tangential acceleration, right? Tangential acceleration. So then tangential acceleration is equal to vector V dot vector A by magnitude of the velocity. Very, 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 very important. So if the angle is not known, directly you can do the dot product. See, moreover, velocity and acceleration are given in the vector form. Then you can do a dot product here by magnitude of the velocity. You will get the tangential acceleration. Very simple. And here V cross A. So this can be written as VA sin theta. Children, A sin theta is what actually? Perpendicular component is nothing but what actually? Centripetal acceleration. So centripetal acceleration is equal to, bring this with this. Children, complete A sin theta is centripetal acceleration. Complete A cos theta is tangential acceleration. Then centripetal acceleration is equal to V cross A by what? Magnitude of the speed. So children, this is how we can calculate the tangential acceleration and centripetal acceleration if angle is not known, and moreover velocity and acceleration are given in the form of vector. It's given in the vector form. Okay, make copy. Retardation. Children, what is retardation? So when I ask what is retardation, immediately many of you can say that, sir, the negative acceleration is called retardation. In fact, many teachers, many, it's almost many, I can say that, I can't say all actually. So many faculty members, many teachers, yes, I too heard they saying that negative acceleration is called retardation. Negative acceleration is called retardation. But children, is it true that negative acceleration is called retardation? Is that the way to understand? Is that the way to get the feel about retardation? Children, if you can learn like that, just retardation is a negative acceleration. Negative acceleration is called retardation. No, you can't understand the concept. That is what actually many students are struggling, to do the numericals in physics simply by adding the definition. So we don't even think really is it true in all the cases or not also. So simply see, as per our knowledge, yes, negative acceleration is called retardation. But children, I can say it is not a correct one. It is not the way to tell about the retardation. Let me give you an example, then you only will tell. For suppose children here, let us take so here is a body, yes, here velocity is acting in this direction, yes, here acceleration also in the same direction, okay. In a second case, so here velocity is in this direction, acceleration is in this direction, clear. And let us take one more case. Velocity is acting in this direction, acceleration also acting in this direction. Let us take a fourth case. Acceleration is acting in this direction, the body motion is in this direction. So let us take 4 situations to have a better feel about the retardation. So meanwhile children, let us recall one sign convention. So as per the sign convention rule children, so yes, so this towards the positive x-axis we can take physical quantities positive, and here is a negative. Of course, this is positive and here is a negative. Children, now you can think, in this first case, is the speed going to be increased or decreased? Children, we discussed already. When acceleration is parallel to the velocity, yes, speed, I mean it's magnitude of the speed, yes, increases, speed increases. When opposite direction, yes, speed decreases. When acceleration is anti-parallel to the direction of velocity, then speed decreases. Okay, here what happens? Acceleration is in the direction of motion, both are same direction. So here speed increases. Now in this case, so both are opposite. So here again speed decreases. speed decreases. But in which case you can say that body is retarded? In which of these four cases body is retarded? So let me tell you children. So here in this case body is retarded. In this case body is retarded. Okay, now look at here children. So in this case both are in the positive direction. So acceleration is positive here. Positive, okay. Here acceleration is negative. So here acceleration is, children, acceleration is again here is negative because in this direction. Here acceleration is positive. Acceleration is positive. So you may get on doubt, sir, acceleration is positive, but फिर it is retardation. How it is possible? We learned that negative acceleration is called retardation. Negative acceleration is retardation. 7th class, negative acceleration is called retardation. 9th class, negative acceleration is called retardation. Even in 11th class also, many lecturers are saying that negative acceleration is called retardation. If it is true, then whatever this, think about the situation. So it is not just a negative acceleration is called retardation, children. Then what actual the definition, how to have the feel about the retardation, children? Yes, so the acceleration which opposes the velocity, the acceleration which tries to decrease the velocity, the acceleration which is always opposite in the direction of the velocity is called actual retardation. If acceleration is opposite to the direction of the velocity, then the velocity keeps on decreasing. As the velocity keeps on decreasing, body is retarded. Got a feel? This is very important. So it is not always the negative acceleration is called retardation. If it was true, children, and here acceleration is positive, in this direction it is acting, but still the speed decreases, body is retarded. Here, and look at here. Here acceleration is negative, but speed is increasing. You can't say this here body is retarded. Here body is accelerated. Body is accelerated. Children, try to understand. Body is accelerated. Though acceleration is negative, but the body is accelerated. So you cannot say that just a negative acceleration is called retardation. No. The acceleration which opposes the speed, the acceleration which opposes the direction of velocity. If velocity and acceleration both are in opposite direction, in that situation only body is retarded. If not, it is accelerated. So till date, whatever you learned the definition, negative acceleration is called retardation. Just forget about it. That is not the way to what we can say learn about the retardation. So retardation is all about the direction you have to see. If the direction of acceleration is opposite to the direction of the velocity, then the body is retarded. In that case only acceleration you should call it as a retardation. It is not just by seeing a number is minus 2. See, you can't say that minus 2 meter per second square is a retardation. No, you can't say that. Plus 2 meter per second square, just you can't say that, just it is acceleration. You can't say that. It can be acceleration, it can be retardation also. Just it depends on the direction. Children, it's acceleration, the velocity, you must talk about the direction only. Got it? Now after listening to our lecture, just go through book. You will understand. You will get the feel. Now recall the concept what given by your lecturers or teachers. Then you will come to know that. So if it is said it just negative acceleration or retardation, it is wrong. Just look at the concept. Concept is important. Clear? Just copy it. Fine. So now children, let me give you an example also. One more best example. For example, let us take here is body is like this. Okay, so now body is thrown vertical upward direction. Yes, like this the body is going. Okay, now so after reaching maximum height, children, let us say that body again coming back. Okay, so in the first case velocity, that is the direction of motion will be upward direction. Clear? Yes. Let's see the first case. This is second situation. Okay, now where here the velocity of the body, hence the direction of motion is downward direction. So this everyone knows. You may get under, sir, what is that in this? Yes, okay. Now let us think about the acceleration due to gravity. Acceleration due to gravity is the acceleration in G. Okay. In the first case, G acts downwards. G acts downwards. Second case also G acts downwards, children. So children, here seems to be a single example, but two cases are there. In the first case, acceleration is opposite to the direction of velocity. That's what here, that's what, it's a magnitude of the velocity keeps on decreasing. Whereas in the second case, the acceleration is in the direction of velocity. That's what, the magnitude of the velocity keeps on increasing. So in the first situation, here body is retarded. Here second situation, body is accelerated. But in both cases, is the acceleration due to gravity negative or positive? Children, downward direction. Remember, that's what acceleration due to, as per sign convention rule, acceleration due to gravity always we consider as a negative, downward direction. Downward direction, downward direction. That's it. See now, same acceleration, okay, same G. Here producing retardation, producing acceleration. Look at here. Here it is minus G only. Here minus G only. So according to the point what we by hearted, then here it is a, what we can say, retardation. Here also it should be retardation, right? Because minus G only. Then the speed should decrease, right? Is it happening? No. Which means what? Whatever the concept which we learned is wrong. It means, wrong means in a particular situation only it is applicable, not all situations. So children, I repeat once again, the acceleration which opposes the direction of velocity is a retardation. That's it. It might be positive, negative. See, in both cases, G is negative only, acceleration is negative only. But here in one case, the body is retarded. In one other case, body is accelerated. The sign is same, negative only. Negative only. That's what I'm telling. Just don't by heart. Negative acceleration is called retardation. No, it's not like that. Here negative acceleration, first case retardation, second case acceleration. So you have to see the direction. You have to see the direction of acceleration. Is it in the direction of velocity or opposite direction of velocity? Okay, now you copy. We have a last point to end the session. Come on. dt. Children, look at here. So in terms of acceleration also we can discuss about the motion, children. So what is the meaning? What if the acceleration of the body is 0? Children, acceleration of the body is 0 means body can be at rest. Yes or no? Yes, body can be at rest. Okay, na? And here velocity remains constant. If velocity remains constant, acceleration is changing in velocity, so acceleration is 0. Such a motion, what we can call, children, uniform motion. Very, very important. Uniform motion. If acceleration is 0, body can be at rest or body can be in a uniform motion. When a body is in a uniform motion, children, yes, we can use this. S is equal simply Vt. Very, very important. So generally we'll be talking about velocity displacement by time. Children, velocity displacement time you can use only body has uniform motion. Okay, fine. Now, if A is a constant, which means what here? A is a constant means V is not a constant. V is a variable. So there is a change in velocity, but in a uniform manner. Velocity is changing in a uniform manner. The changes in a velocity is a constant. The changes in a velocity is constant. So as velocity variable, you consider the uniform motion. Rather, it is a non-uniform motion. It is what, children? Non-uniform motion. Non-uniform motion. So in this case, children, we can use equations of motion. Equations of motion. Children, equations of motion are applicable only when acceleration remains constant. So in fact, equations of motions are derived for an object which is moving with a uniform acceleration. Okay, fine. Now children, if A is a variable, children, if A is a variable, V must be variable. Means random manner it is changing, not in a uniform manner. Must be variable. Random manner it is changing. So even here, it's a non-uniform motion only. It is also non-uniform motion. And here, children, equations of motion are not applicable. You can't use. Why, sir? Sir, why can't we use? Because equations of motion are derived only for an object moved with a uniform acceleration. Here acceleration is variable, so hence equations of motion are not valid. Then if here means by using equations of motion we can calculate acceleration. But here then how can we calculate the acceleration, children? Here only we use the concept of differentiation. We use the concept of differentiation and even integration also. We can use the concept of differentiation and integration. So by using concept of differentiation and integration, we can calculate the acceleration as it is a variable. Okay, fine. Now children, here for these things are there here, which in general, where our students will get confused. Look at here children, what does it mean actually? Children, here dv by dt, here is what actually here? Velocity. There is a change in velocity. Yes, change in velocity simply it is acceleration. No doubt about it, it's acceleration. Okay. But here if you can see, this both are not same. Okay, na? It is a dv by dt, it is a dv by dt, but both are not same like that. Okay, okay. So here there is a change in the magnitude of the velocity. Children, when there is a only change in the magnitude of the velocity, such a acceleration is what? Tangential acceleration. Difference is there. Difference. So this is possible only in one dimensional motion. Of course, it is possible even in 2D also, but only I am talking only change in the velocity, that to magnitude, change in the magnitude of velocity, the tangential acceleration. And whatever this children, so the rate of change of velocity is what? Acceleration. Magnitude, yes, magnitude of the acceleration, what is that? Okay, and here it is what actually? Magnitude of the change in velocity. The change is happening in the magnitude. This is for this only magnitude. So here we will take the magnitude of the acceleration. Magnitude of the acceleration. Children, don't get confused. Just have some patience. Cool. Take a few seconds. Think. Take a decision. You will get it. Otherwise, we will be confused. We will get confused. Clear? Okay, fine. Children, we discussed one last point. So as we discussed here, this differentiation integration. Of course, we are not going now. We are not getting into the differentiation and integration concept. Rather, here, look at here, children. For suppose here, you got what we can say displacement is given, children. Let us say displacement. Okay, we have a displacement. So some function is given, displacement function is given. They asked us to calculate the velocity. So to get a velocity, children, what we have to do? We have to differentiate. So displacement should be differentiated with the time to get a velocity. Okay. But from velocity, how can we get the acceleration, children? Yes. So you have to again do the differentiation, like a velocity should be differentiated with respect to the time to get a acceleration. Very simple, children. So when you differentiate the displacement, we get the velocity. When you differentiate the velocity, you get the acceleration. You may get wondered, sir, if you differentiate the acceleration, we get a jerk. So it's a higher order, it is a jerk. We don't discuss in a 11th, 12th, even degree level also. The rate of change of acceleration, yes, we have one more term, jerk. Okay, fine. So, but our discussion is limited to acceleration only. Okay, you may get wondered, sir, we know how to calculate a velocity and acceleration if displacement is given. But how to calculate the velocity acceleration, if velocity and displacement, if acceleration is given? Is very simple, children. Here we have to see, here completely differentiation, this differentiation, please excuse me, I don't know the spelling, getting confused. It's almost morning, 3:30 or 4, I don't know even time. Okay, fine. So children, so differentiation concept, but acceleration to velocity, children, yes, we will follow the integration method. Integration. So here, if you want to get you want to get a velocity, children, you want to get a velocity. So what you should do? ADT. Okay, means you have to integrate the acceleration to get the velocity. Then how to get the displacement? Yes, so displacement you get when you integrate. Okay, some time intervals and everything is given. Limits. Okay, we are not going in depth as it will. Just rough idea I am giving you. So your displacement to velocity, velocity to acceleration, differentiation concept. Acceleration to velocity, velocity to displacement. It is a integration concept which we are going to use. Okay, children. So this is all about, of course, it might be, I think, a lengthy one only. Children, if you can notice our videos, kinematics, first lecture, second lecture, third lecture, is taking time. But same concept can be explained in 10 minutes also. But our intention is just not to complete the concept and just to upload, right? It's not that. To give you feel, to give you the concept, to give you the knowledge actually. Okay, so that you have to do the numerical on your own. Children, when your concepts are strong, you can do the numericals. If your concepts are weak, you'll struggle with the numericals. That's what I have been telling you. Don't be at the back of numericals. Learn the concept, understand the concept, have the feel of that concept, then start practicing the numericals. You will enjoy, right? So that solving the numerical is a process of enjoyment. But of course, if I say like this, many of you may feel, sir, you tell like that only, sir, but we are feeling a difficulty. We only know that problem. Yes, you know the reason why are you feeling a difficulty in solving the numericals? Because retardation concept. Recall the retardation concept, how we learned till today, and today till date how we learned, but today how we learned about retardation. Okay, children. So thank you so much. All the very best.